All right, so it is, this is what's weird about your homework. So go ahead and write 6-3 in your plan book, but we may or may not get to it. So it's up, it's live in Schoology, but if we don't get to it today, I'm going to extend the deadline, and it won't be due until, we actually get to the lesson. So hopefully we're able to at least start that lesson today, but we need to finish 6-2 first.
I have no idea why my notes aren't. I wonder, but can I take them off? So they know that.
Sure. You know you have them somewhere?
Yeah, I do. What did you do with it?
So this is really convenient. I hate that we've not been finishing lessons, but if it's a struggle for you to find your notes, if it takes longer than, 10 seconds, you need to check your organization system. Because your notes should be in the right section, in the right order, and easy to find, and filled out, hopefully. All of your notes should also have your name on them. I've found a few pages of notes that I have a hard time finding their owner, because people are like, oh, these are mine. I don't need to write my name on it. I don't turn this in. But when you lose it, it would be very convenient if we had your name so we know who you are. So we go to the deli, and we want to buy a sandwich. I used to work at Jimmy John's, one of the many jobs that I've had. We want to make a sandwich. Have you ever been to Jimmy John's and had the gargantuan?
Yes.
The gargantuan has every single meat that they have on one sandwich. When my wife ate meat, I would make a gargantuan and leave it open flat, before they fold it, and cut it in half and make 2 sandwiches out of it, because that's how much meat is on there. So let's say we're making a giant gargantuan sandwich, and it has 1 3/4 pounds of cheese on it. Pounds. It's a gargantuan sandwich. Party sandwich. Yeah. Dude, pound of cheese. I could eat a pound of cheese, and probably once, I eat cheese like it's my job. What, pepper jack cheese? Some crackers? No, some crackers on a sandwich or something. Actually, interesting fact, because I love to throw interesting facts at you, our bodies get so reliant on dairy, when we drink a lot of milk and eat a lot of cheese, it has addictive tendencies similar to that of, I forget what they said. Is it cocaine? I was trying to remember if it was cocaine or heroin. So you know how drugs are addictive, right? You get addicted to what they do to your body. Your body eating cheese and liking that dairy, it gets addicted. So if you eat a bunch of cheese and then you go cold turkey, you would have withdrawal. You would literally have cheese withdrawal syndrome. You can have withdrawal from dairy. So interesting fact, your body can become addicted to foods just like drugs.
My mom has these little Dr. Grilled cheese.
Yeah.
And then I just steal them sometimes.
The little packaged of the dried up stuff. Yeah. Jaheim?
When I used to live in Maryland, I used to go at night and take cheese, the cheese in the plastic things.
Mm-hmm.
Yeah, I used to take them and eat them, big sandwich, a cheese sandwich.
Yeah. Dude, I love a grilled cheese. Last one, then we gotta move on, Jack.
That's scary because I've had milk probably every day of my entire life.
Yeah. So I'm talking if you eat a block of cheese every day, and then you have no cheese at all. We're talking, you have to get to an addictive point. Yeah, but milk is not the big thing. Cheese is the big, addictive thing. So, refocus. If we put this on the digital scale. Digital scales do not work in fractions. If we put this on the digital scale, what number would show, and then we would see LBS. Have we talked about LBS in here? Yeah, it's pounds, but have we talked about Y? Goes back to way back when pounds were originally actually called libras, Libras. I think it's a Greek word, but that's where LBS comes from. That's why. That's our abbreviation for pounds. Who knows? What digital decimal number? Andrew?
It's 2.75.
Ooh,
Wait,
close.
no, sorry,
1.75. Because my whole number comes before the decimal. My fraction of 3/4, we know that that's 0.75. If you did not remember that 3/4 is 0.75, which I would hope that you do, but you can go back up to your ones table, the 1/2, 1/3, 1/4, 1/5, that table, and you could multiply your 1/4 by 3 to get your 3/4.
I just had a question. Are we gonna get our mastery assessment?
So because of garage sale pickups last night, I went around hauling stuff from people's houses. We drive around in the U-Haul. If you guys and you haven't seen the gym yet, but if you haven't yet helped, you should ask your parents about volunteering, and you should come to the garage sale. It's gonna be sweet. There's a lot of cool stuff. I've already bought something. So because of that, and a meeting this morning that we didn't know was gonna happen, we just had to have this meeting. I have your tests graded, but they're not in map, so I can't give them back to you yet. So I will give them back to you tomorrow. Yeah, you mastered it. I already told your mom that you mastered it. So,
Yay!
why is what? That I can't give them back to you? Because I need to put them in the grade book. So I've just not had time to get them in the grade book. And when I give back tests, so you guys have the same test that the other Math 7 class took. So when I give them back, I give everybody's back on the same day. So sometimes it takes me a little bit of time. We want to compute 7/8 the way that we talked about computing based off that table. So remember, this table right up your screen tells you all of the 1 numerators. So if we want to figure out 7/8 down here, obviously the 3 is going to be a 3. But 7/8, can somebody walk me through that process that we did the other day? I think we did it with 3/8 yesterday, but what do I do here? Do you know, Abby?
Isn't it? I know that yesterday we did long division like that, 7 and then.
I could do the long division, but I don't want to. Long division's no fun. Justin?
It is 3.85.
Ooh, that was for 3/8. You were close to 3.75. But what we talked about yesterday was 7/8 is really, and guys, you should write this down, especially since I didn't have any volunteers to help me. It's really 7 times what? 1/8, right? Because 7/8 is having 7 of the 1/8, which really becomes 7 times the decimal form of your 1/8, which if you forget, the table's right up your paper. So then we can do the multiplication, and this actually goes back to a question on your test about the propane tanks. If I distribute this multiplication, I can do 7 times 100, which what is 7 times 100? 700. Then I can do 7 times 25. I could break up the 25 into 20 and 5, but I don't need to go that far. What's 7 times 25? Well, 25, 50, 100. We get up to 175. So when I add these together, I get 875. But because I had 3 decimal places, I still need 3 decimal places. It's 0.875. So my final answer is 3.875
So when,
pounds.
but when they round off the 5.
No, so actually most digital screens, not calculator, but most digital screens will go at least 3 decimal place values. Because the tenths is not that accurate. A tenth of a pound, there's a lot of variance there. 100th of a pound is pretty accurate, but 1,000th of a pound, we don't need to go beyond that. To talk about a 10,000th of a pound is kind of dumb.
So isn't it 3 and
So if we rounded this, Abby, it could be 3.88 if we rounded at the second decimal place, or it would be 3.9 if we rounded at the first decimal place, or approximately 4 if we wanted to round to the whole value. But we normally go 3 decimal places for accuracy.
you should know that.
Any other questions?
No, wait, yes.
No, not at all.
Did you get your water bottle?
Time to do that this week. Quit pressing. So now, if we want to convert from the decimal form back to the fraction form, how do I read this top number properly? When we read numbers properly, you never say the word point.
And
Justin?
725,000.
7. Wait, what?
Just gonna add something how you convert.
Okay. So hold on, give me a second to write this down. So Justin said this, because I stop at the third decimal place, that's my thousandths place. read properly, you should be writing this down, is 7 and 1 are to 25 thousandths. So then, what'd you say, Justin? Well, we need to reduce this fraction, right? Now, the other thing we could do, which I think, because I heard what you said, is recognize the decimal and remember what that is as a fraction. Is that what you did? So what is 0.125? Well, yeah, but what is it as a fraction, like simplified? Because I heard you say it, I think.
Ooh.
If you look back up at your table and compare, Anthony.
It's 7 and 1/8.
Yeah, so 0.125 is really 1/8 if you went back up to the table. But right here, I could start reducing. So ignore your 7. We know your 7 is going to be a whole number. Sorry, no decimal point since we're doing fraction. I initially see that they could both be divided by 5 because they end in 5 and 0. But I can go bigger. They can both be divided by 25. And I don't really want to go much bigger than that because it gets kind of difficult. So if I reduce these, that becomes 5 over, well, what's 100 divided by 25? How many 25s are in 125 is 5. How many 25s are in 1,000 is 40. Then I can still reduce, because they're actually still reducible by 5. So we divide by 5 and get our final value, like we already found out, of 1/8. And that's how we go all the way to the simplified fraction. You need to simplify your fractions. You can leave it improper if you like improper fractions, unless I like to ask you to convert to mixed. But if it's a fraction that can be reduced, proper or improper, you gotta reduce it. We want to work in the smallest numbers possible. So then I bring it over here, and it's 7 and 1/8. So go ahead and try the next 3 on your own. The first step of it's pretty easy. It's the rest of it that gets harder. So you can't like hang upside down, but if you tip your bottle backwards and get your head below your waist, if you can, I'm not joking, it works. If you drink water upside down, because how it like shoots it through your body, or you use a spoonful of mustard, but you don't really have mustard here. But the water trick always works for me. If you have the hiccups, drink water upside down. If you missed our little conversation back there. So
That's so weird.
28 hundredths. What? I've got a lot of odd information. I'm just a weird, nerdy guy. Shane, when I look at 28 hundredths, because I see that I end in the second decimal place here, what can I reduce both of these by? 4? Yeah, I can divide them both by 4, which that's difficult for some people to see, because 28 is divisible by 4. Let's think about it. 20 is divisible by 4. 8 is divisible by 4. So Shane, what's that give me as the fraction? 7/25. Can I reduce any further? Can I reduce any further, Shane? How do you know? Yeah, there's actually another way, a real quick way that we know, Andrew. Prime. I love prime numbers. Whenever you end up with a prime number, you're done. Which is why we love prime numbers, because that means we're done. So this is 7 and 7/25.
This one's like the most simple.
7 and 5/10. Bella, help me out. What can 5 and 10 both be reduced by?
2. Well, it makes 1/2.
So they can't be reduced by 2, though. I agree, it becomes 1/2. Yeah, they divide by 5. So that then becomes 1/2.
Now I
which makes this 7 1/2.
And 7.5 is just.
Right. 0.5 should be a quick one that we recognize. Jaheim, what about 6/10? What can they be reduced by? Yeah, I can reduce both of them by 2 because they're both even. I found this really nerdy shirt that said, you know what seems odd to me? Numbers that aren't evenly divisible by 2. See, I like it because it's mathy and it's punny. Any questions on how we went from decimal back to fraction? Now, Mr. Hall and I were having a conversation. Mr. Hall is the 8th grade math teacher. We are well aware that there's a button on the calculator that does this for you. However, if you are one of the students that's like, oh, they don't see me doing my homework, I'm just going to use this button for everything. Realize that on the mastery, on any mastery or any assessment, even the state assessment, there's a day of no calculator. So please make sure that if you go to use that button, you are able to. I don't care if you use the button. I just want to make sure you're able to do the conversion on your own. So please make sure if you start using that button that you're comfortable with doing all this stuff on your own. Yeah. Yeah, because she had to do it all by hand. So on these calculators, which I have to borrow if you ask me, we have to keep them in a drawer because a bunch of calculators disappear all the time. The button that says table, anything that's above it, that's the secondary function. So you have to hit second, then you use that button. On the TI-30s, the regular ones, it's above the probability button, depending on which version you have. But again, it's a secondary function. So you have to type in your number first. What would you ask?
What is probability?
So we'll get there. It's later in the year is what it is.
Later in the year.
8 1/5. Colin, not here today.
Was here. Yeah, who's here?
Donde están? Well, maybe he's in the restroom. Okay, good. Maylee, 8 1/5. So if I want to convert this to a decimal, what should my goal be for the denominator to convert to a decimal? Because so we have options here. Sorry, I didn't set this up very well. I could go up to my table and get the decimal value. But if I want to compute this out on my own, how do I name decimal values? Like, what's that first decimal place? The tenths place, right? So what that's telling me is to easily go from a fraction to a decimal, if I get tenths or hundredths or thousands or any power of 10, I can easily convert. So can I turn 5 into 10?
Yeah.
How do I do that, Maylee? Yeah, I double it. So since I double the bottom, I double the top, I get 2 tenths, which converts to my 0.2, which gives us 8.2 as my final answer. That's it.
But how did you get 8? Oh, yeah.
The 8 was already there. When we work with a fraction, we forget about the whole number for a moment. And that table at the bottom, guys, I just give that space to you so if you are doing work and you want to write down some fraction to decimal equivalents, like you could use this for repeating decimals or terminating decimals, whatever you want. We're not going to do this together. This is just space for you. When we look at this, 4.6710000 with a repeating bar, the repetend. Casey, do you know why this is not a terminating decimal, even though it looks like it ends in zeros? Yeah, what repeats? What does the line tell me repeats, actually? The 1 and the zeros. So this would be 4.6710000010000010000.
Okay, we get the point.
And it keeps doing that. How do I know what? It does. So because this repetend, sorry, what you asked, the answer to what you asked is it doesn't, but how I know is the repetend tells me that set of numbers repeats as soon as it can. So as soon as this stops, I start back over. And then I start back over. And then I start back over. And then I start back over. Yeah, that's why we don't really like the dots, because it doesn't really tell me. Now I can change where my repetend is, and I can now make it do this, because then when it starts back over, it starts at the 0, 0, 0, 0, 1, then 0, 0, 0, 1, then 0, like, so as long as it grabs that chunk, I could actually, just to show you how I can move the repetend, I could do that and repeat the 0, 0, 0, 1, 0. 0, 0, 0, 1, like, so we can do this any form we want, but just showing that yes, this does continue to repeat. That's why it's not terminating.
Oh, so we weren't supposed to write it down.
Someone was wanting to pass out notes, right?
Izzy, don't you?
Maybe it was last class. But if you want to, Jimmy, let's do it.
Oh, I want a definition of why it is terminated. I slept in these braids for 2 days, but I thought
So let's have a conversation. Who's ever had a coach or a parent or somebody that's ever told you anything like, I need you guys really working hard. I need you to give 110%. I need you to give 200%. I need you to give me 1,000%. Every game ever. So, okay, so you can put hands on. So what, and there's a lot of conversation, I feel like there's a lot of like emotions happening right now. We're very emotional as middle schoolers. Why are you so, like, why is that kind of dumb? Don't tell your coaches they're dumb. That's really bad, unless you want to run. But why is that kind of dumb? CJ? Now, what do you mean you can't go more than 100%? 100%, what do you mean by perfect?
Yeah.
So it's like, it is what you want, right? So I agree that I can't give over 100%. Because if I'm actually giving 100%, I'm giving everything possible, right? So that's like saying, give me 110% of the day. I wish I could get 110% of every day. I wish I could squeeze out an extra 10%, get an extra like 24 minutes or whatever that would come out to be. I don't know. But what if you go to Burger King? Hang on. You go to Burger King, you order. Hey ladies, can we connect with the group discussion? So we go to Burger King, they've got their 10 nuggets on sale for $1.49 right now. We order a 10 nugget meal. But from the back, and this will happen more and more to you guys as you get like friends, from the back you see another Phoenix student, you're like, hey, you got a Phoenix, don't you? You're like, yeah, what's up? They're like, I'm gonna hook you up. So you get your nuggets, you open it up, you have 13.
Oh yeah.
You only ordered 10.
That's what I'm talking about.
So hold up. What, Justin? So wait, can I do over 100%? Like, can over 100% happen? Yes, but when your coaches tell you to give more than 100%, that statement doesn't make sense. That's ability. When we're talking about quantifiable objects, though, we can have over 100% because that just means more than the total or more than what I started with. If we call your height and your weight right now your 100%, by next week, you'll probably be over 100% because you'll be more than that. You're growing, you're developing. So that's what the question comes down to. What is the 100%? So let's say you're doing science fair. In 8th grade, you'll have the opportunity to do science fair, and you are into bugs. So you get a bug population, and your spectacle on male and female bugs. It's very hard to tell the gender of a bug, right? But we know that bugs reproduce, because otherwise we'd eventually run out of bugs. So you start studying this bug population. Year one, these look like ticks, which creeps me out because I hate ticks. But year one, how many bugs do we have here? Justin's going to run the class, it appears. What's up? Question or answer to this?
Question.
Okay.
So this problem would 100% be the original.
100% is our start, yeah. So this is like our start or our beginning of our experiment. So we start with a population.
So that size equals.
So this population starts at 8, right? I can count my bugs, starts at 8. Then after some amount of time, I come back and I check my population, and like Justin just said, it's doubled. It's now 16 because my year one population was 8. So 200%, what's it mean to have 200% of something? Justin already said it. It means you have double. So this really does 2 times the year one population of 8 equals the 16 that we have now. 200% is really 2. This goes back to what we mean by percent. Guys, the word percent, what does cent mean? If you have a century, or cents in a dollar, or I don't know how else we can use cent, but what does cent mean, Izzy? It means 100. What does per mean? If I say I'm going to give 3 cookies per student. Anthony? Yeah, but it's telling me an operation, actually. Casey? Justin? Well, okay, so that's if it's a unit rate per, then it's out of a 1, but it's not always unit rate.
Like how many?
Per actually tells me to divide. So
Oh,
this
yeah,
being
not bad.
percent, guys, percent tells you divide by 100. So the reason 200% is actually 2 times the object is 200% to convert into a number that we can use, we have to divide by 100, which is how I get 2. So then if I have 475% of the year one population, maybe we've waited like, a long time, and now my population's starting to get larger faster. 475% tells me to divide it by 100, which would become what? Shane? Don't solve it yet. I'm not looking for the solution. What does 475% become as a decimal number that I can do math with? Andrew? 4 and 75 hundredths, because when I divide by 100, my decimal shifts 2 places.
And it means
Of tells me to multiply. If you haven't gotten that right on those homeworks by now, hopefully you will. Year one population was 8. So I just multiply 4.75 by 8. And we get, what'd you say? 38. What's up, Xavier? Sweet. So we're going to work on writing out the mathematical. So I'm going to come back to you. One of the big skills that we work towards this year, one of the big standards, is taking a verbal statement, making it mathematical, or taking a mathematical statement, making it verbal, and being able to manipulate and solve those. 200% of 1 is blank. It's kind of a combination of a mathematical verbal statement. So I can change that around to only be math. So Xavier, do you know how to switch that around to only be math and then get to the answer?
So, like,
What would 200% become as a number I can use and multiply with? Remember, percent tells me divide by 100. So if I take 200%, I got to divide it by 100. What's it become? What did Justin say about 200% on that last problem? It is actually blank the original. You can help him out, Justin? 2 times, right? We double it. 200% means you double something. So guys, on each of these, below this, I want you to write the mathematical statement of 2, then of tells me multiply, then of 1 gives me the equal sign. And what do I get, Xavier? I get 2. Lily, 125%. What does that become as a decimal value I can use? Yeah, which then becomes 1.25, because when I do that division, I just shift my decimal 2 places. Of tells me multiply. 100 gives me the equal sign. What do we get? Yeah. No, not point, just 125. Because we take 1.25, multiply it by 100, that moves your decimal places. Izzy, which I can't believe your cards are right beside each other. How do I write the mathematical statement for my next one? What do you get? You can work ahead, by the way. You don't need to wait for us. 150. 400% of 26. Julia.
Okay. It would be 4 times 26.
Yes, ma'am. 4 times 26 becomes... Make this easier. What would 4 times 25 be? 100. Then 4 times that extra 1 that we had. 4 more. You get 104. 125% of 25, Hayden. How do I convert that to math sentence? 1.25 times 25 comes out to be, think about, try to solve this in your head. Did you solve this in your head? So, 25%. What is that as a fraction? David? A fourth, right? If I want to figure out a fourth of 25, because I have a fourth extra. I have all of 25 and an extra fourth. So take your 25, chop it in half first. We get 12 and a half. Chop that in half, we get 6.25. So this is actually going to come out to be 31.25. Because 25 chopped in half is 12 and a half. Chop that in half, 6 1/4. Kylie, 300% of 2. 3 times 2 is 6. 1,000% Atticus of 15. How do I write that mathematically? So remember, percent means divided by 100. So what's 1,000 divided by 100? 10, right? So 10 of tells me, what's of tell me to do? Guys, I love that you want to help your friend, but when I'm talking to a specific student, I'm trying to check on things. Then I bring down my 15. 10 times 15 just gives me 150. And 700%, Justin, of 5. Yeah, so, but how do you get there? 7 times 5 equals 35. Any questions on any of those 8? Okay. Okay. Did you do it in a calculator or what? So how'd you do it? Did you stack multiplication or what? Yeah, there you go. Yeah, check your numbers that carry over. Estimate. No calculators, no tech, no anything. 350%. How could you talk about this amount? 350%. Don't use percent. Start to just reason through what we're actually talking about. CJ, you got any ideas of how we can talk about 350%? Now, what if it was only 300%? Could you say something about 300%? What did we say about 200%? We made the comparison that it really does what to the number? It doubles it, right? So 300% would probably do what to the number? We'd triple it. What if this was 400%? We'd quadruple it. So we're not at 300 or 400. We're right between. So we're between the triple and the quadruple. So compare, what would 300% be? Well, if I tripled my value, I'd get 60. 400% would be 80. 4 times 20, which is 80. So my number will be right between there. So it would be 70. Of all the things I don't want you to memorize, I do want you to memorize the percent formula. And the reason why is it's one of the most important things we deal with this year. The main percent formula that we use is part equals percent times whole. The part of the value will be whatever percent times the entire set. So it's 50%, 0.5. If it's over 100%, we're going to get a part that is bigger than the whole. People get confused about this. Your part is not necessarily smaller than the whole. There's no strict rule for which is bigger. Justin?
So couldn't you just figure out, like, hey, 25 is going to be equal to 5 in this?
What do you mean 25 is going to be equal to 5?
25%, since it 50 is another 10 up, and 25.
Oh, you're back on the other problem? Yeah, we could have. Yeah, we could have chopped and thought about what is 50% of this number. We could have gone to 300 and then an extra 50. So there are a lot of right ways to get to Florida. One destination, a lot of ways to get there. That's how math is. If I haven't said this analogy in this class yet, there are many right ways to get to Florida. If you search Miami Beach in MapQuest or Google Maps or whatever, I guarantee you have options to get there. So, math, we have one right destination and a lot of ways that we can take to get there. There's not that one way is better than the other. It's just different. One way could be faster. That doesn't necessarily make it better. It's just faster. One way might be more scenic and it might let us see more or like do more math. There's a lot of right ways to get to Florida. So this equation is our main application, but that would be really easy if I'm looking for the part. Here, we are looking for the part. The other formulas that we use, I would write these down somewhere because they're pretty darn important, is if I want the percent value, if I'm looking for a percent value, it's part divided by whole, then you have to do the times 100 to actually get it to percent form. And this one's really awkward. If I'm looking for the whole value, it's the part divided by the percent in rate form, so in the decimal form. So it cannot have the percent sign on it. We cannot do math if it has the percent sign on it. So this is whatever the percent is, but in its decimal form as the rate. So that's why they look at 130%. Now, I do not like their process here. I disagree with their process, but I wanted to show it to you for a reason. They take their 130% and set up the division by 100. But they don't do the division by 100 to the 130. They instead do the division by 100 to the 800, which you can do because the commutative property lets me move things around And actually, I think that's more like associative property. But this is 130 times 800 times 100th. Like the fraction 100. So they use this division by 100 on the 800 instead of on the 130. So please be aware that's how they get to that. The other option here would have been 1.3 times 800, and that would have still gotten the right answer. So if we were solving it, we would have done it this way, the 1.3 times 800. When we talk about 200% of a quantity, we already, thanks to Justin, knew that that's double. But so student A says Justin's answer. He says 200% of 1 is 2. Student B says 200% of 1 has to be 200 because it's 200%. This is where the misconception comes in. You can't do the math with this number. So what would you tell student B? What would you communicate? Abby?
Like, you really, you have to do it, like, maybe, like, they did, like, 200 times 1, but they didn't, like, student B did not divide 200 by 1.
So what we could tell them is you must convert percent to rate form before solving. We must convert the percent into rate form, which is the decimal form, or fraction. The fraction shows the rate as well, before we solve it. So student A is the correct student, obviously. All right, that's all the time we have. Thank you guys very much. We will pick up your notes here tomorrow, and who knows how far we'll get. I don't know.
Yeah, I don't know why they're racing.